is x to the 1/2. Find the antiderivative of this by adding 1 to the power and dividing by the new power. 1/2 plus 1. I hope you recognize by now that this is x to the 3/2 over 3 over 2. I'm pretty much out of space. Plus c. So far so good, I hope. I'll zoom out a little bit so you can see the rest of the writing. And then 1 over 8 x to the 6th. Again, some things never change. You will need to rewrite the x to the 6th. And again, this is just saying find the antiderivative of 1 over 8x to the 6th. We talked about this kind of 1 over 8th thing before. So we talked about this the other day, and my pen here is a little bit too thick. But this 1 over 8 is really a coefficient. So I can make this, I can make this 1 over 8 x to the negative 6. And then, so that was another rewrite. You had to move the variable out of the denominator just like for the derivative. But now we'll keep the 1/8, add 1 to the power, which I'm just going to do here. It's negative 5. Put this over negative 5 and add c. I'm not that concerned about whether or not you simplify it, but this is really gross the way it's written. I can combine the 8 and the 5 together to make a 40, and it's negative, so I have negative 1 over 40, x to the negative 5th plus c. Moving on to the next example. Find the antiderivative of the square root of x to the 5th. So this is the antiderivative of x to the 5/2. So think about that. I had to rewrite the root. It's a square root, so outside that little root is a 2, and it's x to the 5th power, so it's the inside 5 over the outside 2. As usual, we add 1 to the power, 5 over 2 plus 1. I don't want to throw you off by not writing it down. 5 over 2 plus 1 is 5 over 2 plus 2 over 2. Oops, I gave you the answer, which is 7 over 2. Over 7 over 2 plus c. Again, I'm not that concerned about whether or not you multiply by 2/7. I'm good as long as you actually understand what we're doing. Now we'll move on to a new rule. The constant rule for integration. This shouldn't be at all surprising. This should be very much like what we did for derivatives. So I'm going to find a bunch of derivatives first, and then talk about their corresponding antiderivative. So if f of x equals 4x, the derivative is just 4. So therefore, if I work backwards, I start with the derivative. So then the antiderivative of 4 dx would have to be (4x). Just based on what we know about finding derivatives, we know that the antiderivative of 4 would have to be 4x. Technically, plus c. Now looking at another example. If f of x equals negative 16x, hopefully you know the derivative by now, is negative 16. So then I'm asking you to look in reverse. So these should swap places. So I'm looking for the antiderivative of negative 16. That should give me an answer of negative 16x. Of course, plus c, because when we work backwards, we always have this plus c. I think I changed my color coding, but it's okay. This one might seem a little bit weird. You are accustomed to seeing e raised to the x power. Please be aware this is not e to the x power. This is e times x. So e is the coefficient on the x. Believe it or not, e is the coefficient. So the derivative is e. So then, again, working backwards, They'll swap places. The antiderivative of e better be e with an x attached to it, plus a c. So that leads us to a new rule, the constant rule for integration. If you are looking for the antiderivative of some constant k, the antiderivative is k times x plus your arbitrary constant c. Now we'll try some examples of these. Again, this won't let me zoom up for some reason. Okay, so take a moment and make sure you have all that, because I'm going to need to shrink this to be able to... Oh, the examples aren't here anyway. Yeah. See, I told you I wasn't sure what I was doing with this. Anyway, next page. Here are the examples. The antiderivative of negative 3 dx. Oops, oh my. The antiderivative of negative 3 dx is negative 3x. Don't forget your plus c. I want you to notice the difference between question 1 and question 2 is nothing more than a different letter. So what should the antiderivative of negative 3 dz be? It better not be negative 3x. It's negative 3z. This letter tells you what the letter you're using is. So how about 2 dt? This will be 2t plus c. So whenever you have a constant, the antiderivative just attaches whatever the variable is to that constant. Again, this next rule should make some sense. Again, I was able to scroll up before, but now I can't scroll up. I can scroll down, can't scroll up. Okay, so let me try to move this around a little. Okay, let me try to clean this up a little bit so it's slightly less confusing, but now we can still see the stuff at the bottom. So there's a sum and difference rule for integration, which again shouldn't really be very surprising. It works the same way as it did for the derivative. So if f of x is 2x squared plus 4x, the derivative better be 4x plus 4. So again, if we work backwards, same idea. They're going to swap places. The antiderivative of 4x plus 4 better be 2x squared plus 4x. But take a moment to think about where the 2x squared and the 4x came from. 2x squared came from 4x, adding 1 to its power, which is 1 plus 1, so it becomes 2, divided by 2. The antiderivative of 4, we just learned, will be 4x. This reduces to 2x squared plus 4x. So what I just did was found the antiderivative of the 4x and added it to the antiderivative of 4, which is exactly the same way we found the derivative when we added or subtracted. So you'll just find the antiderivative of each individual part of the sum or difference. So for x to the 1/2, the derivative is 1/2 x to the negative 1/2 minus 4x cubed. And then working backwards of that, you'll just find the antiderivative of each one of these. 1/2 x to the negative 1/2, add 1, divide by the power, they cancel, minus 4x to the 4th over 4. Oh, I forgot to add c's. And you can see this brings you back to the original. So the rule says, if you have f of x plus or minus the antiderivative of f of x plus or minus the antiderivative of g of x, you can literally just find their antiderivatives independently of one another, plus or minus. I keep not doing that right. It's not letting me write the minus in. Anyway, moving on to the next page. Here are some examples. In reality, even though technically this is the way the rule is written, and I'll write it up here because you may not have been able to really see it at the bottom, the antiderivative of f of x plus or minus g of x is found by taking the antiderivative of f of x plus or minus the antiderivative of g of x, which is what I did here. I split them into two parts. See how there's the minus in between? I split it at the minus into two separate antiderivatives. In practice, no one ever does that, but you get the idea. You'll then find the antiderivative of x to the 2/3, which you get by adding 1 to the power and dividing by the new power. The antiderivative of 4 dx is just 4x. I also again want to keep making this clear. You're always just pulling out the thing trapped in the middle. Pull out the thing trapped in the middle and do something to it. If it's got a variable already, you add 1 to the power and you divide. If there is no variable, you just attach the variable on. 2/3 plus 1 would be 5/3. But again, normally, you just do them piece by piece, keeping the plus or minus in between them. Our next rule is the coefficient rule for integration, which again shouldn't really come as a surprise. It's very much the same as what we did for the derivative. So if you are given any real number coefficient, which we're calling little c, I probably should have called it k, you are allowed to pull the coefficient out of the integral. Again, in practice, no one really ever does that, but there have been a few times where I felt like this rule was applicable and did it. But the point is, just like in the derivative, coefficients are sticky, not constants. There's a difference between a coefficient and adding on a constant. When you add on a constant, that's addition, but when you have a coefficient, that's multiplication. So when you have a constant being multiplied, that thing just sticks around and lingers and just hangs out. So let it do its job, let it just sit there and wait to use it. So like this one, 5x minus 2 dx. I could split this into two integrals, but again, in practice, no one really does that. You're just finding the antiderivative of 5x minus 2, which means you want to find the antiderivative of 5x, which you find by adding 1 to the power and then dividing by the new power. Minus the antiderivative of 2, which will be 2x. And then we always add on our arbitrary constant. This next one, which I may not quite have the space for, we'll figure it out though. You need to rewrite this before you can do anything. The square root of x is x to the 1/2. And again, just keep in mind what this thing is asking of you. It wants you to find the antiderivative of the thing in the middle. And the thing in the middle has two parts. The antiderivative of x to the 1/2 will be add 1 to the power. 3 over 2 over 3 over 2. This coefficient 3 is attached. It stays. Add 1 to the power, you're going to get 5 over 2. Plus c. And again, I don't so much care if you actually simplify this. Let's just take a look at it. Hopefully this is starting to make sense.